Okay, so last time we saw the definition of bounded function. So function is not bounded on set A, or f is unbounded on set A if for every m. So there is no m means what? So function is bounded means what? Ki f is bounded if there exists number m such that absolute value of fx is less equal m for all x. At each x, the value of function lies in between minus m and m. So there are two numbers which bound the value of function. That means function is bounded. So function is unbounded means there is no m. So that means for every m, there is x, right? For which f of x is greater than m. So such function is called as unbounded. So how will you prove that f of x equal to 1 by x is unbounded on 0 to 1 or on R? Right? So how will you see this? Prove that 1 by x is unbounded. To prove f of x is equal to 1 by x is unbounded, so on 0 1 what we need to do, so we show that there is no m such that absolute value of f of x is less than or equal to m for every x in this 0 to 1. Right. So we want to prove that there is no such m. Okay. So on the contrary, suppose there exists m such that absolute value of f is less than or equal to m for all x in 0 to 1. Suppose there is such m, then what happens? What happens? Right? There is m which bounds function. Then is it true? Is it true there is a number m which will bound the function? Yes. But if x is equal to 1 upon m plus 1, what about this number? Then is x in 0 1? Is x in 0 1?
Yes, sir.
And what is f of at this x? Is 1 upon 1 by m plus 1. What is this? M plus 1,
M plus 1.
which is greater than m. Contradiction. Right? That means you choose any m and it is a bound for function, then I can produce. Alright, I will give you x which in the domain at which function is greater than that m, right? So 1 by x, if you give me any m, I will give you x which is sufficiently close to 0, right? I will choose x for which at which value is greater than m. From this figure you can see for any m I can produce x at which value is greater than m. So therefore this function is not bounded. Now how to prove some function is bounded or not? So for example, let f defined on 2 comma 10 to r, what is f of x is equal to f of x is equal to x square plus 5x plus 3 divided by x square plus 1, x square plus 1. So prove that f is bounded on the domain 2 to 10, right? So how will you prove this? Suppose now you want to find, to prove that f is bounded, we need to find a number such that ki f of x is absolute value is less than or equal to m for each x is in 2 to 10, right? So how to produce m? You understand, we want to produce a number m so that we can declare that the function is bounded. Yes, is it clear?
Yes, sir.
That is, want m such that, so what is our function? Want m such that x square plus 2x plus 3, x square plus 5x plus 3 upon x square plus 1 is less than or equal to m for all x in 2 to 10. So we want this. Okay, so try to find out m. Let us try to find out m. So since okay, for x is in 2 to 10, we have 2 less than or equal to x less than or equal to 10, right? So x is in 2 to 10 means x lies in between 2 and 10. Therefore, what is x square plus 5x plus 3? By triangle inequality, absolute value of x square plus absolute value of 5x plus absolute value of 3. But here x is positive, x square is positive, so it is just same as x square plus 5x plus 3. So here x is positive, so absolute value of 5x is same as 5x. But then if I choose the largest possible value of x in our range, what is our range for x? 2 to 10. And what is the largest possible value of x in this range?
10.
10. And therefore if I replace x by 10, right, if I replace x by 10, then I will get larger value, right? X, right, in previous step x is in between 2 to 10, but if I choose the largest value of x which is 10, then I will get the largest quantity, 100 plus 50 plus 3, so 153. This is the one thing, correct? Next, so we want to find m which will bound this expression. That means we should find the upper bound for numerator. And what about denominator? What about denominator? So what we want?
Lower bound of
Lower
this.
bound, because x square plus 1, we want to find something greater than this. So we want to find some number p which is greater than this. So that means we want to find x square plus 1 number smaller than this, right? So we want to produce a number which is smaller than x square plus 1. So absolute value of x square plus 1. Since this quantity is positive, so no need of absolute value sign. And x square plus 1 in this range, right? The range for x is 2 to 10. And what is the least possible value of x in this range?
2.
So 2 square plus 1, right? Which is 5. But if you choose the smallest value, the quantity will be smaller, right? Therefore 1 upon x square plus 1 is less than or equal to 1 by 5, right? What is this? This is for x is in 2 to 10. This is for x is in 2 to 10. So if you choose any x between 2 to 10, the x square plus 5x plus 3, the absolute value is less than or equal to 153, and this next. So therefore for x is in 2 to 10, what is absolute value of fx? Is absolute value of x square plus 5x plus 3 upon x square plus 1. But absolute value of a by b is absolute value of numerator divided by absolute value of denominator, right? But the absolute value of numerator is less than or equal to 153, and absolute value of 1 upon x square plus 1 is less than or equal to 5, right? Now this is our number m, and thus what we found, the f of x is less than or equal to 153 divided by 5 for all x in 2 to 10. Is it true? So the number m which we wanted to produce is, this is our number m. Correct? So is it clear?
Yes, sir.
Yes, sir.
We are able to produce some number. So from this can we conclude? Hence, f is bounded on 2 to 10. So clearly this function is bounded. Fine. Okay, so here the function was simple so that we could say that it is bounded, but sometimes things could be very difficult, right? So, so let f of x is equal to, okay, first of all, sine 1 by x, does limit x tends to 0 sine 1 by x exist? Does this limit exist?
No.
No, right? We have already proved it. Now let us consider another function. So let fx is equal to x sine 1 by x. Right, so it is defined everywhere except 0. Right, this function is defined everywhere. At every point it is defined except 0 because we are not defining it at 0. Right, now
सर
question.
सॉरी सर आई इंटरप्ट यू कोई तो मुझे निकाल रहा है मीटिंग से कुछ चेंजेस करते हैं क्या आप
What?
कोई तो है कि मुझे मीटिंग से निकाल रहा है क्वाइट कर रहा है मेरे हर बार कर रहा है प्लीज सेटिंग चेंज कर रही हूँ
Okay, I will check the record, and who is doing this I will identify later on, because I will get all the information who is removing somebody, then I will identify such students. Okay, so if somebody is intentionally removing some other student, so I will identify such students. Then I will see what to do with such students. Right, so don't be like uh, irresponsible students. Yes, if you have any doubt, you can ask me, but Such nonsense cannot be tolerated. I have a record of each and every activity. Okay, so f of x is equal to x sine 1 by x. So question is, does limit x tends to 0 x sine 1 by x exist?
Yes, sir.
So answer is yes.
Yes.
Right. So you can check this. So or prove that limit x tends to 0 x sine 1 by x is 0. Actually limit is 0. So how will you prove it? So how will you prove it?
We know that the x is not equal to 0, x tends to 0, so sine 1 by x will take values between -1 and 1, whereas x will take values closer to 0, and by the product we will get 0.
No. Product will not help us. Right. If you using the product rule, then what about 1 into sine 1 by x? 1 into sine 1 by x. That means sine 1 by x. But this limit does not exist. Right? When I say sine 1 by x means it is 1 into sine 1 by x. So this limit does not exist. So you have to have some concrete way. Right? We'll see some other results also, but you should have some concrete way. What is that concrete way to? So obviously here you can use epsilon delta definition. So give an epsilon, find delta, right? So such that, so consider what kind of delta we want key fx minus 0. Can you make it less than epsilon for suitable choice of delta? So x sine 1 by x minus 0, which is just absolute value of x into absolute value of sine 1 by x. But this is less than or equal to absolute value of x. Right. So we want to find delta such that what type of delta we want to find? What type of delta we want to find? Such that whenever distance of x from 0, that means x minus 0 is less than delta, then distance of fx and 0 is less than epsilon. So such delta we want. Distance of x from 0 means absolute value of x. So what is the suitable choice for delta from this last expression?
Epsilon.
So choose delta same as epsilon. Then if delta is same as epsilon, then if distance of x from 0, which is actually absolute value of x, is less than delta, then what is fx minus 0, which is less than or equal to absolute value of x, which is less than or equal to delta epsilon. So delta is equal to epsilon, that's fine. So in this case we can produce delta for epsilon, and therefore limit x tends to 0 x sine 1 by x is 0. So this is clear. And is this function bounded? Is f bounded? Right? What is the domain for this function? What is the domain of this function? Yes.
Real minus 0.
So except 0 it is defined everywhere. Therefore domain is bounded on r minus 0. And so here it is not easy to check whether it is bounded, because you cannot say that x sine 1 by x is less than or equal to x, and x is bounded. But x is not bounded because what is the domain? x varies over r. So this will not give you some number m. Do you understand? Yes.
Yes, sir.
Therefore, this idea will not work in this case. Limit exists at 0, but what is the guarantee that it is bounded? So we have next theorem. So let A subset of R and C belongs to R be cluster point of A. Suppose let f is a function defined on A. So if limit x tends to if limit x tends to C, fx exists, then f is bounded in some deleted neighborhood of C. So alternatively, that is, if limit of f at C exists, then f is bounded in some deleted neighborhood means then f is bounded near C. Near C, that means in the neighborhood of C, function is bounded. That means there is some number m, right? If you assume that this theorem is true, then what can you say about this function? Is it bounded? Yes. Is
Yes,
this
sir.
right? And okay, we'll see that later on, but let us see first of all proof of this theorem. So, so what is given? What is assumption or hypothesis? So limit x tends to C fx. So limit x tends to C fx exists. Right. Okay, let limit x tends to C fx is equal to L. Suppose limit is L. It exists means it is some number, that number is L. So what is our claim? F is bounded in some deleted neighborhood of C. That is, f is bounded in some deleted neighborhood of C means what we want to prove. Yes.
There exists some m.
And if this is C, in some neighborhood function is bounded. We are not worried about other parts. So near C, because we are talking about limit at C. So near C, it's definitely function is bounded. So C minus delta, C plus delta. Right. So in some neighborhood, certainly function is bounded by some number m. So that means what? There exists m and delta such that absolute value of fx is less than or equal to m for all x in what?
C minus delta to C plus delta.
Right. C minor delta to C plus delta and except C because C may not be point in the domain point of domain, so x is not equal to C. If x is equal to C, no problem. If function is defined at C, then no problem at all. But in more general sense, if it is not defined at C, then we cannot include C. Anyway, this is our aim. Once our aim is clear, so how to start the process? How to start the now what is our aim? What we want to produce? What is our aim? What we want to produce? We want to produce m and delta. Okay, there is delta in that delta neighborhood. There is m such that key function is bounded by m. Right? Okay. So since limit x tends to c f of x is equal to L, this is given, only thing is ki limit exists. Suppose limit is L. So for epsilon is equal to 1, for every epsilon, by definition of limit, for every epsilon there exists delta. In particular, for epsilon is equal to 1, does there exist delta?
Yes, sir.
Right, so there
Yes, sir.
exists delta such that whenever distance of x from c is less than delta, then distance of fx from L is less than 1. Right, for every x whose distance from c is less than delta, this is going to happen. Therefore, if distance of x from c is less than delta and x is in the domain, then what can you say about fx? Is it less than some number? Yes, I am looking at now fx. I got some delta here and I am looking at that delta. That means I will choose the x c minor delta to c plus delta. I will choose all those x whose distance from c is less than delta, means x lies in between c minor delta to c plus delta, may not be equal to c and in the domain of function. And then I am looking at what is f of x, but I will add and subtract L by triangle inequality, fx minus L plus absolute value of L. Okay, what should I write next?
It's less than 1 plus absolute value of L.
Right, 1 plus absolute value of L. Is it a finite quantity?
Yes, sir.
Right. Now can I call this as my M which I wanted to produce?
Yes, sir.
Yes, sir.
Yes, sir.
So therefore, if x belongs to c minor delta to c plus delta intersection with a, x is not equal to c, then certainly absolute value of f of x is less than or equal to m. What is m? 1 plus absolute value of L. This is a constant, right? Therefore, f is bounded in v delta dash c. So this deleted neighborhood of c.
Excuse me, sir.
Yes.
Sir, we are taking the case that x is not equal to c, but if f of c is defined,
Then no,
then f of c can be greater than m, no?
no problem. In that case, no problem. If function is defined at c, then same bound you can have. Okay, same bound in the sense. Okay, let me. Uh, we are not worried about one point. Why? We are not worried about value at one point, because whatever value of function c, okay, I will give you the example basically. Let f of x is equal to x plus 1 if x is not equal to 2 and 100 if x is equal to 2. Do you understand the function now?
Yes, sir.
Fine. Okay, so can you see this function f of x equal to x plus 1? Graph of this function. Here it is 2. And except 2, it is x plus 1. And add 2, what is the value of function?
100.
100.
100.
So this graph has a break at this point. as a small hole. Do you understand?
Yes, sir.
Here is a small cut at this point, small cut, because up to 2 it is same as x plus 1 and after 2 also. So x is not 2 means from left side of 2 and from right side of 2. So it is x plus 1 and it is small cut at 2 and at 2 value is 100. Fine. Now questions are, does limit x tends to 2 fx exist? Yes.
Yes, sir.
Yes, sir.
So what is limit x tends to 2 fx?
3.
3. Very good. Now is function defined at 2?
Yes, sir.
Yes, sir.
Defined at 2. Yes. What is f of 2?
100.
100. Fine. So f of 2 is equal to 100. Now is f bounded near 2?
Yes, sir.
Right, so you choose any neighborhood around 2, definitely function is bounded, right? Definitely function is bounded, but see, if you look at this deleted neighborhood, then it is function bounded by f of whatever you choose, suppose 2 plus delta, this number. So function is bounded by this number, but so function is bounded near 2, it is true, right? Because f of x is less than or equal to some m for all x in deleted delta neighborhood of 2. But if I want to say that key, what is this number t such that f of x is less than or equal to this number t for all x in whole neighborhood, not deleted in
Maximum of m and 100.
so t is equal to maximum of m and 100, because we are worried about when we consider deleted neighborhood, the only one point is excluded, and if function is defined at that point, its value is some finite number which is 100 in this case, and you compare the m and that value and choose maximum. That will be the bound. So is it clear?
Yes, sir.
Your doubt is clear now?
Yes, sir.
Right. So if function is defined at a point, then it is better. Well and good, because certainly it is a finite value. Certainly we can produce a bound. Right. Okay. So if now remark, what is a contrapositive of this? So what is the statement? If limit x tends to c fx exists, then f is bounded near c, that is f is bounded in a neighborhood of basically deleted, because function may not be defined at c of c. What is a contrapositive? Then means what it implies. So what is a contrapositive statement? Our statement p is limit x tends to c fx exist. What is our statement q? F is bounded in a deleted neighborhood of C, and what we have, P implies Q. This is equivalent to, this is equivalent to what?
Not Q implies.
Negation Q.
Right, not Q implies not P. That means, what does it mean? Not Q means what?
F is not bounded.
F is not bounded in
Deleted neighborhood of C.
E. What is the statement Q? F is bounded in a deleted neighborhood, some neighborhood, right? And what is the negation? F is not bounded in any neighborhood. Am I right?
Yes, sir.
Then what? Then what?
Limit of F does not exist.
Limit x tends to C, Fx does not exist. Right, so this is another criteria for non-existence of limit. And for example, prove that limit x tends to 0, 1 by x does not exist. And now the idea is clear. How will you prove this?
Yes, sir.
So it is not bounded in any neighborhood of 0. If you take any neighborhood of 0, function goes larger and larger. Right. So is fx is equal to x sine 1 by x bounded near 0?
Yes, sir.
Right, so yes, because limit exists. Fine. Now here limit of x sine 1 by x is 0. So limit x tends to 0, x sine 1 by x is 0. Even sine 1 by x limit does not exist. And limit of, also note that limit x tends to 0, x is 0. And limit x tends to 0, sine 1 by x is does not exist. Right. The limit of one factor does not exist and limit of another factor is 0. Can you say that limit of product is 0? Yes.
No, sir.
No. Limit of one factor is 0 and limit of another factor does not exist. But here it exists. Here it exists. So, what is the general theorem? Suppose the preamble is constant, same. A is a subset of R, C belongs to R, is a cluster point of A, F is defined on A. Okay, now we are interested in two functions. So G is another function defined on A. So uh, if limit x tends to C, f of x is 0 and G is bounded in some neighborhood of deleted neighborhood basically of C, then limit x tends to C fx into gx is equal to 0. The limit of product is 0. The statement is clear?
Yes, sir.
Okay. So what is the statement? If one function has limit 0 and another function is bounded near C, then limit of product is 0. That's it. Simple statement. Limit of one function is 0 and another function is bounded, Okay, limit of product is 0. Right. So what is given? What is given? Limit x tends to c fx is equal to 0. What is second thing? G is bounded near c. That is, there exists delta 1 such that near c means in some neighborhood there such that what? There exists delta 1 and m such that. What next?
Mod of g of x is less than m for all x belonging to
Right.
deleted neighborhood of.
For all x in c minor delta to c plus delta intersection a, because we can think about points in domain and x is different from c, because g may not be defined at c, that could be a problem. Otherwise, if we include c, then also no problem. Right. Okay, so what is our claim? What is our claim? Right, so this is our claim. So naturally, how to prove this? What should I do? What should be the natural strategy?
For given epsilon, we should find delta.
Given epsilon. What is in my mind? Want to find delta such that whenever distance of x from c is less than delta, then distance of fx into gx minus 0 less than epsilon. So this is in my mind. I want to find epsilon is given, somebody gives you epsilon, now your job is to produce delta. Right, so how to do this? So first of all, try to simplify the expression. So from that you will get we can have strategy. So fx into gx minus 0, it is just fx into gx, but it is same as absolute value of fx into absolute value of gx. But we know that g is bounded. G is bounded. Can I say that this is less than or equal to m into absolute value of fx for all x is in this delta 1 neighborhood of c intersection a, deleted delta neighborhood of c. Am I right?
Yes, sir.
Fine. Now, see, my aim is I want to make this quantity less than epsilon. Right, fx into gx minus 0, but fx into gx minus 0 is less than epsilon means it is sufficient to make m into fx less than epsilon. Can I make m into fx less than epsilon? Is it possible? Yes.
Yes, sir.
So how will you make, this less than epsilon? So m into absolute value of fx less than epsilon if what?
F of x is mod of f of x is less than epsilon by m.
Right. So mod fx is less than epsilon by m. So mod fx is less than epsilon by m. Now is it possible to make absolute value of fx less than epsilon by m?
Yes, sir.
Yes, sir.
So absolute value of fx means it is actually absolute value of fx minus 0. Fine. So what is the strategy now? So from this we can have a strategy. What should be the next step? What should be my strategy? Epsilon is given, and we know number m also, which is a bound for g in this neighborhood. So what is the strategy?
Limit of f of x at c is given as
0,
0.
so there exists delta 2, because already there is a delta 1, right? Already there is a delta 1, right? So which in that neighborhood g is bounded. So there is delta 2 such that f of x minus 0, which is f of x is less than epsilon whenever 0 less than x minus c less than delta 2. So c minus c plus delta 1, c minus delta, c plus delta 2, c minus delta 2. So we have two neighborhoods, right? Delta 1 neighborhood and delta 2 neighborhood. But so in which neighborhood both of things will be true? It is less than or equal to m into fx, and fx is less than epsilon upon m. So what's the proper choice for delta?
One which is minimum.
Smaller minimum
Minimum.
of delta
Because
1
in
and delta 2.
minimum, right, if you choose smaller of them, both of things are true. So choose delta is equal to minimum of delta 1 and delta 2. So choose delta is equal to minimum of delta 1 and delta 2. Then check whether this is the required delta. Whenever distance of x from c is less than delta, so when I say distance of x from c is less than delta, delta is already minimum, so it is less than delta 1 as well as delta 2. Right. So when I say x minus c less than delta means distance of x from c is less than delta 1 as well as delta 2. So fx into gx minus 0, which is fx into gx. But distance of x from c is less than delta 2. So for such x, this is less than or equal to m times fx. Since distance of x from c is less than delta 2, right, distance of x from c is less than delta 2, then absolute value of fx is less than epsilon upon, okay, we want here epsilon by m. We have produced for epsilon 1 is equal to epsilon upon m, right? For epsilon 1 is equal to epsilon upon m. Epsilon is already given, m is also known, so epsilon by m is a positive quantity. For that epsilon there is a delta 2, right? This is less than m into epsilon by m, which is epsilon. Thus, whenever distance of x from c is less than delta, then distance of fx into gx minus 0 is less than epsilon. Hence, can we conclude that for any epsilon we can produce delta?
Yes, sir.
Right,
Yes, sir.
is equal to 0. So this is a general result. So therefore, if you have function limit x tends to 0, x sine 1 by x, and using this above theorem, can you prove that limit is 0? Why? I will call f of x is equal to x and g of x is equal to sine 1 by x. Then what is limit x tends to, here c is equal to 0. So what is limit x tends to 0? Fx is 0 and g of x is bounded. So g is bounded and therefore limit of product is 0 by previous theorem. So limit x tends to 0 fx into gx, which is limit x tends to 0 x sine 1 by x is 0. The question arises, if G is bounded and limit x tends to C fx is equal to L may not be 0, then does limit x tends to C fx into Gx exist? Yes. If limit of fx is non-zero, is the theorem applicable in this case? Yes.
No, sir.
No. For example, no.
Sine 1 by x.
Right. If I choose function hx is equal to sine 1 by x not equal to 0, and I will take fx is equal to 1 and gx is equal to sine sine 1 by x. Then what is hx? Fx into gx. So what is limit x tends to 0 fx? So limit x tends to 0 fx is 1, right? Limit exists but non-zero, and g is bounded, right? But limit of fx into gx does not exist, right? Therefore, this what is the speciality or what is the key point in this theorem?
Limit of fx is equal to 0.
Right. That means if g is bounded and limit of fx is 0, then limit of product is 0, otherwise not. Fine. Suppose all above conditions are there. A is a domain, C is a cluster point, whatever. Limit x tends to C, fx is equal to L. Then can I say that limit x tends to C absolute value of fx is absolute value of L? Is it true? Yes.
Yes, sir.
And what is the proof? Proof is straightforward. So we are assuming that limit is L. So we want to prove that limit of absolute value of fx is absolute value of L. So given epsilon, what we want? Delta, such that whenever distance of x from C is less than delta, then distance of minus absolute value of L is less than epsilon. This is what we want. And is it possible? Given epsilon, since limit of fx is L, so there exists delta such that whenever distance of x from C is less than delta, then distance of fx from L is less than epsilon, that we know. Therefore, so note that absolute value of A minus absolute value of B is less than or equal to A minus B. This triangle inequality. Therefore, if distance of x from C is less than delta, then what is distance of absolute value of fx minus absolute value of L? which is less than or equal to absolute value of fx minus L. Is it less than epsilon?
Yes, sir.
Right. And so for any epsilon, same delta works, right? So therefore, limit x tends to c, absolute value of fx is equal to absolute value of limit. But absolute value of L, what is L? Limit x tends to c fx. What does it mean? The limit of absolute value is absolute value of limit, right? So is converse true? Is converse of above theorem true? That is, what is the converse? If limit of absolute value of f exists, does this imply limit x tends to c fx exists? Yes. What we proved, if limit of f exists, then limit of absolute value function exists. Now what is the converse? What is your guess?
Not true.
Not true. Right, it is in some sense similar to the sequences. So not true. For example, so let f of x is equal to 1 if x greater than 0, minus 1 if x is less than 0. Right. Then what is absolute value function?
1.
Is it true for all x?
Yes, sir.
Right. Okay, include 0, no problem. For everywhere this function is constant. Therefore, what is limit x tends to 0 of absolute value of x?
1.
1, right? So limit exists. And what is limit x tends to 0? Right hand limit of fx if you approach from the right side. Now sketch the graph of this function. What is a graph? How will you sketch? For x positive it is constant 1. For x negative it is constant minus 1. This is a graph of f. And therefore if we approach from right side, that means x approaches 0 from right side. So x is here at present and it is approaching towards 0. So if x is here, where is f of x? F of x
1.
is 1. So when we approach from right side, so it is 1. And what is the limit? 1. So limit x tends to 0 from left side. But if we approach from left side, what is f of x?
Minus 1.
Right, at present x is here and therefore function is minus 1 and therefore limit is minus. So right hand limit, if we approach from right side and if we approach from left side, not same. So can we say that limit x tends to 0 fx does not exist? Correct?
Yes, sir.
Therefore, absolute value function limit exists, but the original function do not have limit. So the converse is not true. Correct? Okay, so we'll stop here. Next time we'll see the algebra of limits. That means sum of limit of sum, product, limit of product, and all these things we'll see next session. So if you have doubt, you can ask.